Today we're going to talk about proportions and scale factor. And our first question that we have to answer is, what is a ratio? A ratio is a comparison between two quantities. There are three ways to represent a ratio. They're each said the same way, but written differently. The first would be something like A to B using words. Another way is using a colon. We still say A to B. And the last way is using a fraction bar, A to B. An important note is that ratios can be simplified. And we will simplify our ratios when we determine scale factor. Now, what is a proportion? A proportion is an equation that states that two ratios are equal to each other. And when we see a proportion written, it's usually written as A to B is equal to C to D. In any proportion, the product of the means is equal to the product of the extremes. This is an important phrase and an important statement. Now, what this means is that in a proportion, these are my means because they're in the middle of my proportion, and these two are my extremes because they're on the outsides of the proportion. So what it really means is that in any proportion, I can multiply those middle two numbers, B times C, and they should equal A times D. Now, you might be familiar with a term known as cross multiplication, and you can use the term cross multiply. The issue that some students have is that they have a difficult time remembering when to cross multiply and when to multiply across. So I avoid that, and I just say we're going to use the means extremes property and use our product of our means is equal to the product of our extremes. So let's go ahead and look to solve a proportion. So looking at number 1, I'm going to use my highlighting to help me. But if you don't have a highlighter, you can circle your cross products. But we're going to find our means, our two inside numbers, and our extremes. And I'm going to show that those are equal to each other. So I'm going to show that 8 times x is equal to 5 times 12. Well, 8 times x is 8x. 5 times 12 is 60. To get x by itself, I can divide both sides by 8 and get x is equal to either 15 over 2 in simplest form or 7.5 because it is a terminating decimal. Now, to get 15 over 2, which, like I said, is in simplest form, I could divide both my 60 and my 8 by a common factor, and in this case, it's 4. Let's try number 2 now. This time we have an expression in our proportion. So again, the product of our means is going to be equal to the product of our extremes. So I'm going to write it out. 9 times 2 should be equal to 3 times x minus 2. And this is why writing it out comes in handy, is because right now I'm going to need to distribute 3 to both terms of that binomial. 9 times 2 is 18. 3 times x is 3x. And 3 times 2 is 6. I'm going to solve my equation now. And I get x is equal to 8. One last one. This time I have 2 expressions. Again, the product of my means is going to be equal to the product of my extremes. So let's start with my means. 5 times 2p minus 11 should be equal to 7 times p plus 2. Again, I'm going to need to distribute. 5 times 2p is 10p minus 55. And 14p, 7p plus 14. My hands are getting ahead of my head. There we go. All right, to solve for p, again, I'm going too fast. We're going to subtract 7p to both sides because I want to get all those p's to one side of the equal sign. 3p minus 55 is equal to 14. If I add 55 to both sides, I'm going to get 3p is equal to 69. And I can divide by 3 to get p by itself. P equals 23. That is how we solve some standard proportions. Now let's see how that's related to some word problems. This first one says, what is the ratio of 750 milliliters to 1.5 liters? Now for this one, you're going to note that the units are different. And if I have different units, I cannot make a comparison using a ratio yet. Well, I can, but I can't simplify the ratio. It would help to get them in the same units. So that's what I'm going to do. I'm going to take this 1.5 liters and I'm going to convert that to milliliters. And I'm going to use the fact that 1 liter is 1,000 milliliters to help me. So if 1 liter is 1,000 milliliters, then 1.5 liters should be 1,500 milliliters. Now I can more accurately compare them. I can compare milliliters to milliliters. So I'm going to show 750 milliliters compares to 1,500. And I want to get this in simplest form. So to do that, I'm going to think of a common factor. I happen to know that these are both divisible by 750. If you can't remember that right off the bat, which a lot of us probably can't, we can divide by a common factor that you might see. Some people think of 10 in this case, might think of 25. Then see if there's another common factor that you can divide by again to get it until you can no longer divide by a common factor. But in this case, we see that it's a ratio of 1 to 2. Now we're switching gears a little bit. We don't have any units, but the ratio of two unknown numbers is 2 to 5. Is it possible that the numbers are 2 and 5? Is that in a ratio of 2 to 5? Well, yeah. But let's write it down and figure out why. So 2 to 5, I'm going to rewrite this as a fraction from up here. And then I'm going to rewrite this as the second fraction. And I'm going to check to see if the product of my means and the product of my extremes are equal. Well, if I were to cross multiply, or again, use my means extremes, I would get 10 is equal to 10. So yes, 2 and 5 could be those numbers. What do we think about 20 and 50? Again, if the ratio is 2 to 5, and I need to see if that's the same as the ratio of 20 to 50, I can write that out, and then you figure out the product of my means and the product of my extremes. Is 5 times 20 equal to 2 times 50? Is 100 equal to 100? It is. So again, yes, it could be 20 and 50. The next one says, are they in a ratio of, or could they be 6 and 20? So let's see. Is the ratio 2 to 5 the same as 20 or 6 to 20? Here are my means and here are my extremes. Is 5 times 6 going to be the same as 2 times 40? Ugh, no, it is not. So because those cross products are not equal, 6 and 20 are not in the ratio of 2 to 5. Let's see how this relates to scale factor. So when I have scale factor, we're going to first determine, we have these two triangles, QRS and ABC. And that first one on the left says, what is the scale factor of triangle QRS to triangle ABC? And notice the order in which it's stated. QRS compared to A, B, C. Corresponding parts matter. So in order to determine the scale factor, I want to know what number we could multiply by to get from QRS to ABC. So I'm going to just highlight for you one pair of corresponding sides. Here's another pair. And a third. You could pick any of these corresponding sides you want, and in fact, you can pick them all if you'd like. But when we determine scale factor, notice that we're getting bigger. So from 3 to 12, I multiplied by 4. Is that the same from 5 to 20? And from 7 to 28? That means that the scale factor from QRS to ABC is 4. To get that number, we actually do have a formula. We can take a side in our image and place it over a side in our pre-image. As long as they're corresponding sides. So let's go with the 3 and the 12 again. In my image, it's 12. In my pre-image, it's 3. So the scale factor is 4. Let's look at it in reverse. From ABC to get to QRS, I'm going to take a side in my image and put it over a side in my pre-image. One pair of corresponding sides. Again, we can pick this 12 and 3. But this time, 3 is in the image. So it goes on top. Now 3 and 12 both share a common factor. That factor is 3. So the scale factor is 1/4. And order matters, guys. If the scale factor, or K, is greater than 1, the size of the figure will increase. Look at the shape on the left. It got bigger when the scale factor was bigger than 1. Compare that to the one on the right. If the scale factor is less than 1, the size of your figure will decrease. Let's determine the scale factor again. From ABC to DEF. That means that ABC is my pre-image and DEF is my image. So I'm going to use the ratio of my image over my pre-image, and I'm going to pick a pair of corresponding sides. I'm just going to go around and label my corresponding sides. You could, again, pick any of these corresponding sides. You will still get the same scale factor. I'm going to pick the pink sides, 10 and 15. Again, this is my image. Might help to write it on it. And this is my pre-image. So I'm going to put 15 over 10. I'm going to find a common factor. In this case, it's 5. And divide. So the scale factor is 3:2. And you're going to ask yourself, does that make sense? Did it get bigger because 3/2 is greater than 1? And yes, your image is bigger than your pre-image. Now let's try this. We're going to find the scale factor that maps ABCD to WXYZ, and we're going to solve for M. So the first thing that we need to do is find the scale factor itself. So to find the scale factor, like I said before, we're going to find some corresponding sides. So I'm going to go again around and match them up based on the names. AB corresponds with WX, BC with XY, YZ with CD, and WX with AD. So now I can see that to determine the scale factor, I'm going to need to compare two corresponding sides that I know. I see that the yellows only have one side labeled. The green sides, again, only have one corresponding side labeled out of the pair. But blue has both the sides labeled, so I'm going to use that to determine my scale factor. And again, I'm going to put my image over my pre-image. 15 is in my image, 10 is in my pre-image, and that's still a ratio of 3 to 2. Now that I know the scale factor, I can solve for m. I'm going to take my scale factor and say that again, the ratio of my image to my pre-image is 3 to 2. So now I'm going to compare that to the side that's m and its corresponding side in my pre-image, 12. Now we're going to use some cross multiplication, some means and extremes to solve. So 2 times m is 2m, and 3 times 12 is 36. I can divide both by 2 and get m is equal to 18. One last thing we're going to do, we're going to figure out how to do this on the coordinate plane and determine scale factor. This one says figure B is the image of figure A. Determine the scale factor. So to determine scale factor, what you're going to do is first off, make sure that you know which is the image and which is the pre-image. B is the image. So it got smaller. So we're going to take a side in our image. In this case, why don't we determine that this is 2? And we're going to put that over a corresponding side in our pre-image. Well, I'm going to just go with the bottom because it's straight across. 1, 2, 3, 4, 5, 6. 2 to 6 or 1 to 3 in simplest form. And again, if B is my image, it got smaller. This next one says line M is the image. Maybe I'll even highlight the image. Okay. Line M is the image of line L after a dilation centered at the origin. Determine the scale factor. So sometimes it's not nice and neat for us on a flat line. Instead, we're going to have to find the center, in this case the origin, and we're going to count from the center. So L is 2, but that's my pre-image, which goes on the bottom of my ratio. And line M, ooh, how far is that from the origin? 1, 2, 3, 4, 5. So this scale factor is 5 to 2. Now, if you need more help with dilations, see another video on my channel where we'll be dilating figures